boys and girls, it's Miss Bissell. Need you to take out your math journal. We are getting ready to go over your 15 test questions from your Topic 7 assessment, adding and subtracting fractions and missed numbers. So as we go through, if you want to forward the video, if you didn't miss any of the first several problems and you want to forward up to where you started missing any problems, that's fine. As I go through this, you're welcome to watch the whole video. This is a good time for you to make notes out to the side of any problems that you missed, analyzing why you missed them, so that you can ask me questions if you still don't understand. So, great. So just like we talk about in class, your test is delivered on a digital platform. You are to take the problems, write them on your paper, and work them, and then record your answer back on the digital platform. So I'm not having to toggle between different screens. I am actually just going to work them on the printed copy of your test. So let's look at question number 1. Question number 1. Hannah completed 3/4 of her homework on Saturday morning, and she completed 1/8 of it Saturday night. How much homework has she completed? So to get the total amount she's completed, we're going to need to add these two fractions, 3/4 and 1/8. So you already realized that you have unlike fractions, so we have to find the common denominator of 4 and 8. Looking at 8, the larger of the two denominators, I know that that is a multiple of 4, so I'm going to use that 8 as the common denominator. All right, just a review. Whatever we multiply the denominator by to get the old denominator by to get the new denominator is what we're going to multiply the numerator by. So 1/8 is not going to change. 3/4, we multiply 4 times 2 to get 8. And we multiply 3 times 2 to get 6. So just to review, when we scale up by a fractional form of 1, which when we multiply by a numerator and denominator that are the same, that's scaling up by a fractional form of 1, we're writing an equivalent fraction that names the same amount as the original fraction. We're ready to add. We get 7/8. 7/8 does not simplify. 7 is a prime number. Its only factors are 1 and 7. 7 is not a factor of 8, and we don't divide by 1. We would get the same fraction. So our answer is A. Number 2, Jack ran 7/8 mile in a race. Taryn ran 1/4 of a mile. How much further did Jack run than Taryn? How much further is indicative that we're going to be subtracting to find that difference in their distance. So 7/8 minus 1/4. So Jack's time or mileage minus Taryn's. Again, we need to find that common denominator. We're working again with 8s and 4s, so that common denominator is 8. 8 is a multiple of 4, so that works perfectly. I'm going to multiply the denominator by 2, so I'm going to scale up the fraction 1/4 by 2/2, that fractional form of 1, to get that like equivalent fraction of 2/8. 7/8 will stay 7/8. We're not changing the denominators, or if you like symmetry and you want to see, you're going to be scaling up by 1/1. When we subtract, 7/8 minus 2/8 is 5/8. 5, the only factors of 5 are 5 and 1. 5 is not a factor of 8. We don't divide by 1. 5/8 is in simplest form. Our answer is B. So again, hopefully you're looking at what you're missing or what mistakes you're making or where maybe some of your misunderstanding is. All right, let's move on and let's look at question number 3. Max spent half an hour reading before dinner. After dinner, he read another 1 and 1/8 hours. What is the total time Max spent reading? The total amount of time. We're just going to add those two amounts up. So we have 1/2 that we will be adding to 1 and 1/8. Since we're adding, it doesn't matter that we don't have a fraction to add to, but we do need to come up with the like denominators. Oops. the common denominator of 8 and 2. I'm looking at that. 8 is a factor of both of them. So 8 times 1 is 8. So we're going to scale up by 1 over 1. So 1 and 1/8 is going to stay the same. 1/2 is going to get scaled up by 4 fourths. And I know that because 2 times 4 is how I get 8. So 1 times 4 will give us 4/8. You guys all know just from some number sense that 4/8 is equivalent to 1/2. Here are those like fractions and mixed numbers from 4th grade. 4/8 plus 1/8 is 5/8. You're going to add 1 plus nothing. You get 1 and 5/8. 5, the only factors of 5 are 1 and 5. 5 is not a factor of 8. We wouldn't simplify or divide by 1. So 1 and 5/8, answer C. All right, number 4, John ate a total of 3/4 a pizza in 2 days. He ate 1/2 of it yesterday. How much did he eat today? So if you think about it, we've been working with bar diagrams all year. So he ate 1 whole pizza over a 2-day period. All right. Sorry. My bad. He ate 3/4 of a pizza yesterday. He ate 1/2 today. So I want to know what was the difference. So we're going to need to subtract to find that missing fraction. All right, so 3/4 of a pizza is what he ate in a total period over 2 days. That's the total amount. He ate 1/2 yesterday. So if we subtract what he ate yesterday, what's left over will be what he ate today. All right, looking at 4 and 2, my least common denominator is 4. Using that shortcut method, 4 is a multiple of 2, so that works perfectly. We multiply 2 times 2 to get to 4, so we're going to scale up 1/2 by the fractional form of 1 2/2 to get a new equivalent fraction of 2/4. 3/4 will stay 3/4. We're not changing anything in the denominators. All right, if you like symmetry and you want to multiply that 3/4 times the fractional form of 1, of course, we're using 1 over 1. 3/4 minus 2/4 gives us 1/4. Now, that's not going to simplify. It's a unit fraction. And I box it in and find that my answer is A. All right, number 5, another pizza question. Bailey ordered 3 large pizzas for a party. At the end of the party, some of each pizza was left as shown below. If all the pieces are put together, what fraction of 1 whole pizza is left? So here's the leftovers. We're going to put them all together. So basically, we're going to be adding 1/4, 1/8, and 3/8. Now, if you didn't want to work with all 3 add-ins, you could go ahead and add 1/8 and 3/8 or 4/8 and add 1/4 to 4/8. Either way, we're going to all get the same answer. When I work with the denominators 4 and 8, I know that the LCD, least common denominator, is 8. It's a multiple of 4. 3/8 is not going to change because I would only be multiplying the denominator and numerator by 1. Same with 1/8. All right, what is going to change is I'm going to multiply 4 times 2 to get to 8. So an equivalent fraction for 1/4 is 2/8. Here we are. Right, there's your 4th grade objective to be able to add and subtract fractions and mixed numbers with like denominators. 2/8 plus 1/8 plus 3/8 gives me 6/8. That answer is not going to be in the answer bank. It's not been simplified. So factors of 6 are 1 times 6, 2 times 3. So we're going to simplify by the greatest common factor. So let's just work largest factor down to smallest. 6 is not a factor of 8. 3 is not a factor of 8. 2 is a factor of 8. And we already have it in our factor list for 6. So we're going to divide or scale down by that fractional form of 1 2/2. 6 divided by 2 is 3. 8 divided by 2 is 4. So we get 3/4, and that will not simplify. The only factors of 3 are 1 and 3, and we wouldn't simplify by 1. 3 is not a factor of 4. So my answer for number 5 is B, 3/4. All right, moving right along. Number 6. Katie worked 7 3/4 hours on Saturday and 6 2/8 of an hour on Sunday. How many more hours did she work on Saturday than Sunday? So we're going to take 7 3/4 hours from Saturday, subtract those 6 2/8 hours from Sunday. I know right away I'm going to have to bring over the whole number and fraction bar so that I can write an equivalent fraction. 4 and 8 are my denominators, so we know 8 is a multiple of 4, so that is going to be our least common denominator. 6 2/8 is not going to change. Looking at the denominators, we would be multiplying or scaling up by 1 over 1, so that gives us the same fraction. Looking at the top fraction denominator, 4 times 2 is how we get 8. So we multiply denominator and numerator by 2. Scaling up 7 3/4 by 2/2, we get the equivalent fraction 7 6/8. We're going to subtract. 6/8 minus 2/8 gives us 4/8. Whole number, 7 minus 6 gives us 1. Now, looking at my numerator, factors of 4 are 1 times 4 and 2 times 2. Looking to see if there is a common factor. We want the greatest common factor, so I'm going to look and I notice that 4, my greatest factor of 4, is a factor of 8. So we're going to simplify by 4 fourths, or scale down by that fractional form of 1 to get an equivalent fraction of 1.5 hours. Answer choice D is correct. All right, and again, I'm reminding you that when you take a test on a Chromebook, whether it's a chapter test, whether it's a benchmark or an integrate test, or even if it's just a practice buddy or boom cards or quizzes assignment, you guys are looking at the questions on the digital platform, writing them, and we do our math on paper. And then once we get our answer, we look for the answer on the digital platform, or if it's open response, we enter it on the digital platform. It's not just for us to look up here and pick A, B, C, and D and move on. The work is in the paper. All right, number 7. Mila has half of a package of crackers. Bella has 1/4 of the same package of crackers. How much of a package of crackers do they have all together? That is indicative that we're going to be adding 1/2 and 1/4. We need that common denominator. Looking ahead, I know it's going to be 4. I always check the shortcut method and I look to see if the larger of the two denominators is a multiple of the smaller. If so, then 4 is a multiple of both. 1/4 is going to stay 1/4. I would just be multiplying the denominator times 1. So I can multiply the numerator by 1. 1/2 is going to change to 2/4. 2 times 2 is how I get to the denominator 4. So I'm going to scale up 1/2 by 2/2. There we go. 2/4 plus 1/4 gives me 3/4. My only factors of 3 are 1 and 3. 3 is not a factor of 4. We would not simplify by 1. We'd still have 3/4. Our answer for number 7 is going to be D. All right, number 8, moving right along. Miss Purcell's class worked in 3 groups. 1/4 of the students read. 5/8 of the students worked with Mr. Crabtree. The remainder of the class worked on an art project. What part of the class worked on the art project? All right, so we have 3 groups of students. I love the bar diagrams if I need to make the sense of something. So this is Miss Purcell's whole class, one whole class. 1/4 read. 5/8 worked with Mr. Crabtree. So this that's missing are the people or the students who worked on the art project. So I can clearly see that this is going to be a 2-step process to find the answer. If I add 1/4 and 5/8, and I find out what fraction of the class were either reading or working with Mr. Crabtree and then subtracted it from the whole class, what's left are those students that worked on the art project, which is what I'm asked to find. So step 1, I need to add 1/4 and 5/8. So we can work on that first. Our common denominator is 8 for 4 and 8. It's a multiple of 4. You know what? 5/8 is going to stay 5/8. 4 times 2 is how we get to 8. So we're going to scale up the fraction 1/4 by 2/2 to get the equivalent fraction 2/8 for 1/4. When I add together, I get that 7/8 of the class either worked with Mr. Crabtree or read. So this is 7/8 of the class. I want to know what part of the class went to the art project or worked on the art project from the whole class. So what I'm going to be doing next is taking one whole and subtract from that 7/8. All right, now one whole I need to rewrite so that I have some eights to subtract. So looking at the denominator, I need to rewrite one whole as 8/8. Okay, one whole class is 8/8 if I'm working with eights. 7/8 from 1/8 or from 8/8 is 1/8, and that's a unit fraction. It's not going to simplify, so 1/8 of the class is what I believe my answer to be. Now this one's pretty easy. If I know 7/8 of the class is working on either reading or with Mr. Crabtree, and I add the 1/8 that works on the art project, that does give me 8/8, which is one whole. So I can check it. My answer is answer choice D, 1/8. All right, number 9, Veda's cookie recipe calls for 3/8 of a cup of yogurt. She has 1/4 of a cup of yogurt. How much more yogurt does Veda need? So how much more? So I take what she needs, which is 3/8. I know she doesn't have enough, so if I subtract her 1/4 of a cup that she has, it'll tell me how much she needs. I can already tell you that I need to work with equivalent fractions. 8 is the LCD of 4 and 8. 4 times 2 is how I get to 8. So I multiply the numerator by 2 to get 1/4 and 2/8 are equivalent fractions. 3/8 is going to stay 3/8. I would only be multiplying that denominator and numerator by 1, so it's going to stay the same. 3/8 minus 2/8 gives me 1/8, which is a unit fraction. It's not going to simplify, so my answer is going to be A. All right, number 10. The average weight of a basketball is 21 1/10 ounces. The average weight of a baseball is 5 1/4 ounces. How many more ounces, does the basketball weigh? That's indicative that we're going to subtract. So from the basketball weight, 21 1/10 ounces, I'm going to subtract the baseball's weight of 5 1/4 ounces. I already see I have unlike denominators. Bringing over the whole numbers and the fraction bars. Now I can focus. Now, I can't use 10. 10 is not a factor of 4, so the shortcut method doesn't work here. I could multiply 4 times 10. I get 40. That's a pretty big number. I could use it. That is a common denominator. But hopefully those of us that know our times tables know that 20 is a smaller common factor of 10 and 4. 10 times 2 is 20 and 4 times 5 is 20. So if you used 40, that's fine. You're just going to have to make sure you simplified your answer. I'm going to go ahead and use 20, the least common denominator. Looking at my denominators of 4, I'm going to multiply 4 times 5 to get to 20. So I'm going to multiply 5 1/4 times 5/5 to get the equivalent mixed number of 5 5/20. 21 1/10, I'm going to be multiplying that denominator by 2 to get to 20. So 1 times 2 is going to give me 2/20. All right, now I'm ready to subtract. I notice I have one small situation here. I can't take 5/20 away from 2/20. So I'm going to use that skill of regrouping. I'm going to take one whole off of the 21, and I'm going to just rename it as 20/20. 20/20 is one whole, and it will help me have enough 20ths that I can then subtract from. So now I'm going to tidy this up. This is going to be 20 and now 22/20 for my minuend, and 5 and 5/20 is what I'm going to subtract. So now I'm ready to look at those fractions. If I subtract 5/20 from 22/20, I get 17/20. If I subtract the whole number 5 from 20, I get 15. 17 is a prime number. 17 is not a factor of 20, and we would not simplify by 1. So 15 and 17/20 is in simplest form, and there it is. Answer choice B. All right, let's move on and let's talk about number 11. Noah has 5 yards of wrapping paper. He uses 1.5 yards to wrap a small gift and 2 1/3 yards to wrap a large gift. How much wrapping paper will Noah have left? All right, to make sense of this, this is what I'm thinking. I know all together he has 5 yards. That's what he started with. I know that he used 1.5 on the small gift, and he used 2 1/3 on the large gift. So this is what I want to know right here. What does he have left? Well, I know if I add what he's used, the 1.5 and the 2 2/3, and I subtract that amount from 5 yards, that tells me how much he has left. So this lets me see this is a 2-step problem. We've been working on these types of problems all year long. We use the bar diagram kind of to make sense of what our steps are going to be. So let's go ahead and add 1.5 and 2 2/3, step 1. All right, I know that I'm going to have to make those common denominators. Don't forget, we got to bring over the whole number with the mixed number. 3 is not a factor of 2, so 3 times 2 gives me a common denominator of 6. That's the easiest common denominator. It's also the least if I did a multiple list. All right, writing those equivalent fractions. 3 times 2 is how we get 6, so we are going to scale up 2 halves times 2 2/3 to get 2 4 6. I am looking, and I think I've already made a boo-boo. Yep, right there. That's supposed to be 1/3. All right, let me go back and fix my work. See, even your math teacher can make a careless mistake. All right, so my add-ins were 1 1/2 and 2 1/3. All right, so that's going to change what I scale up by. Not going to change what I scale up by. It's going to change the numerator. So if I multiply 1 times 2, I get 2. There we go. All right, let's look at the top fraction. We multiply 2 times 3 to get to 6. So we're going to scale up 1 1/2 times 3/3. So we get 1 3/6. So when I add, I get that 3 5/6 right here is the amount that's been used, right? Out of 5 yards of wrapping paper that Noah started with. So now I'm going to have to subtract from 5 the used amount, 3 5/6. One small little thing here. When I go to subtract, I cannot take 5/6 away unless I have some sixths to subtract from. So I'm just going to rename this 4 wholes, and 6 6 would explain what I did with that 1, right? 4 with 6 and 6 6 is still 5, but it just gives me some 6 6 to subtract 5 6 from. 1 6. 4 minus 3 is 1. The fraction part is a unit fraction. Now, if I want to check it, I can go back and add the 3 of them, or I could just put with 3 5/6 the 1 1/6 and check it and make sure that it equals 5, and it does. So 1 1/6 is answer choice A, so that makes me feel even better. All right, so numbers 12 to 15 were open response, and I created these to look very much like they're going to look in any kind of a check-in or end of grade test, because when you enter open response questions, it goes against everything we know. We need to write mixed numbers as improper fractions so that computers can read them correctly. So that's what I've asked you to do. That's what I have in red that was popping up large on your computer screen. So I personally like to stack my factors or stack my fractions when I'm adding them. So I'm going to add 5 1/2 and 2 1/8 this way. If you wanted to work them another direction, that's fine. I can go ahead and tell you that we're looking at the common denominator of 8 and 2, and using the shortcut method, it's 8. 8 is a multiple of 2. So 2 1/8 is going to stay 2 1/8. We would just be multiplying the denominator times 1. So numerator would be staying the same. Now look at 5 1/2. We multiply the denominator 2 times 4 to get to 8. So we multiply the numerator by 4, 5 4/8. We're ready to add. We always want to make sure that we're obeying the sign. So I get 5/8 when I add the fractions together and 7 when I add the whole numbers. 5/8 does not simplify. The only factors of 5 are 1 times 5. 5 is not a factor of 8, and we wouldn't divide by 1. We'd still have 7 5/8. Now, we cannot put this in the computer as a mixed number. So what we have to do is we have to use that skill of rewriting a mixed number as an improper fraction. So we could model it. We could draw 7 holes, break them all in 8s, and then draw another 5/8 and add it. Or we could use that reverse C algorithm. And basically, we multiply the whole number times the denominator and then add the numerator. And the reason that works, think about it. In 7 holes, there are 8 8s, right? So 7 times 8 means there's 56 little 8s in 7 holes. And then we have 5 8s with it. So that gives me 61. And then, of course, we're working with 8s. So I get 61 8. So when you typed that in on your computer, you type 6 1. The forward slash is what we use on our keyboard for the fraction bar. And then you keyed in the 8. And then your answer would have been correct. Now, there is one thing you could do real quick if you wanted to check and make sure that you changed your mixed number to the correct improper fraction. You can always, just on your paper, check. All right, with division, 61 divided by 8 is 7 times. 7 times 8 is 56. When you subtract, you get 5. That becomes your numerator. You have 5 left over out of 8. So 7 5/8, you know that's what you started with. That's correct. You have 61 8 as the correct improper fraction form of 7 5/8. All right, let's look at number 13. Number 13, you are going to be subtracting 3 2/3 from 7 5/6. So again, I like to stack them whenever I can. 7 5/6 minus 3 2/3. All right, looking ahead, I need to bring over my whole numbers and fraction bar because I have unlike fractions. 6 and 3 are my denominators. 6 is a common denominator. It is a multiple of 3, so the shortcut there helped me find it so quick. Looking at 3 and getting to 6, I know I multiplied by 2, so I'm going to scale up by 2 halves. So I get 3 4/6. 7 5/6 is going to stay 7 5/6. I'm only multiplying that 6 times 1, so I'd multiply 5 times 1. All right, I'm subtracting, so 4/6 from 5/6 is 1/6. 3 from 7 is 4. I need to rewrite my answer, which will not simplify. It's a unit fraction. I need to simplify it by using that algorithm. So we call it the reverse C. We know that we have 6, 1/6, and 4. So 6 times 4 is 24. Plus that other 1/6, that gives me 25/6. So again, in your computer, you would have hit the keys set to 5 / for the fraction bar and 6. All right, to check it, if you want to make sure before you submit your test, divide 25 by 6. 6 goes into 25 4 times. 4 6s are 24. 1 left over, so you have 1 out of 6 parts left over. 4 1/6 is what you started with. Real quick check on these. Number 14, we're going to be subtracting 2 5/6 from the whole number 5. All right, so we have the whole number 5, and we are subtracting 2 and 5 sixths. Right away, I notice that I need some sixths from which I can subtract 5 sixths. So I'm going to rename 5 as 4 wholes and then one more whole, but that one other whole is going to be renamed 6 sixths. All right, now I'm ready to subtract. 5 sixths from 6 sixths is 1 sixth. 2 from 4 is 2. All right, 2 and 1 sixth needs to be rewritten. So I'm going to look at that reverse C algorithm. In 2 wholes, I have 12 sixths pieces plus one more 6. So don't we multiply the denominator and the whole number and add the numerator. So we get 13 sixths. So in your computer, you would have put 1, 3, /6. To check it real quick, let's just change 6/13 back to an improper fraction. 6 goes into 13 2 times. 2 sixths are 12. We subtract, we get 1 left over out of 6 parts, which is what we started with. So we know we converted it correctly. All right, number 15. This is the hardest question on the test, and just the hardest because it was a couple steps, but we've worked these in class. All right, 10 and 5/8 minus the sum of 4 and 3/4 plus 2 and 5/8. Now, I made a note on your computer that said make sure the fraction part of your mixed number answer is simplified before you rewrite it as an improper fraction. So we'll get to that once we get to our answer. We'll revisit that. Right now, we need to worry about getting the answer. So for number 15, and I'm going to put a star, some items have to be more difficult on others than others. So we have 10 and 5/8 minus the sum of 4 and 3/4 plus 2 and 5/8. So obviously, I'm going to have to start order of operations. I start with what's in parentheses. So I'm just going to work the problem underneath. We did that some in class so we could get used to it being worked different ways. All right, so I need to look at those denominators. 4 and 8. 8 is the least common denominator using the shortcut method. 8's a multiple of 4. So what am I multiplying 4 by to get to 8? I'm multiplying it by 2. So I'm going to have to multiply 3/4 times the fractional form of 1, 2 halves. So 3 times 2 gives me the new numerator 6. The 4 stays the same. We're only working with the rewriting the fractional part. All right. 2 and 5/8 is going to stay 2 and 5/8. I know 8 times 1 is 8. So if I multiply the numerator 5 times 1, it stays 5. All right, so next step. From 10 and 5/8, I'm going to be subtracting, let's see, that's going to be 6 and 11/8. All right, so I am going to stack it now because I think I'm going to obviously have to do some regrouping, and I do that better if I stack my problem. So I'm just going to drop right here. 10 and 5/8 is what I am subtracting 6 and 11/8 from. All right, so now I can very clearly see I don't have enough 8s to subtract. So I'm going to rewrite 10 as 9, and then I'm going to use a fractional form of 1, 8/8, so I have enough 8s. So that's going to be now 9, and 8 plus 5 is 13/8. From that, I'm going to subtract that 6 and 11/8. Love it. I have plenty of 8s to subtract now. So when I get 2 8s when I subtract my fractions, get 3 and 3 when I subtract the whole number. Now, I have my answer, and there was a note about something I need to do before I rewrite it as an improper fraction. It says make sure the fraction part of your mixed number answer is simplified. All right, well, I look at that. I know that 2 is a factor of 2 and 8. They're both even. So don't want to lose the whole number. That stays 3. 2 divided by 2 is 1. 8 divided by 2 is 4. So I get 3 and 1/4. Now, going to put this in my computer, but before I can do that, I have to rewrite it as an improper fraction. So there's my algorithm. I know that there are 4 fourths in one whole. So 4 times 3 tells me there are 12 fourths in 3 wholes plus 1 more fourth. That gives me 13 fourths. So I'm going to put this in my computer as a 1, a 3, a forward slash, and a 4. And the computer will read that as 13 fourths. I'm going to check it real quick. Make sure I converted or changed the mixed number correctly to the improper fraction. Just change it back. So 4 goes into 13 3 times. 3 groups of 4 is 12. Subtract, I get 1 left over out of 4. 3 1/4 is what I started with. So I'm going to put in that 1 3/4. All right. So boys and girls, I worked your 15 problems for you. Hopefully you can see what you are doing right and what you are doing wrong, and maybe even something you could do better or more efficiently. All right. So again, that was your Topic 7 assessment, all your goals with adding and subtracting mixed numbers. All right. Have a good day.